You know that Wi-Fi you're using right this second? It feels completely seamless, almost like magic. But behind that magic, there's actually an invisible map, a hidden structure called a topology. Today, we're going to pull back the curtain and see how all your devices are secretly organized. So just think about it for a second. When you connect your phone to your smart speaker or your laptop to the internet, what is actually going on in the background? How do they really connect? Let's dive in and figure that out. Okay, so let's start at the very beginning with the absolute simplest connection you can possibly make. We're talking no routers, no internet, just two devices talking directly to each other. This is our first building block. This is what we call an ad hoc network. The technical term is an independent basic service set, or IBSS for short. But what's really important here is what's not here. There's no router. There is no central device managing everything. It's just a temporary peer-to-peer connection. You know, the perfect real-world example of this, using AirDrop to send a photo from your phone to your friends. That little temporary link that pops into existence for just a moment, that's a classic ad hoc network. It's simple, it's direct, and it disappears as soon as its job is done. All right, so ad hoc is great for those quick, direct links. But what about the Wi-Fi you use all day, every day? The one that's always on? Well, for that, you need a central hub, which brings us to the most common setup in the world. And this is it. This is the big one, infrastructure mode. Seriously, if you have Wi-Fi at home, if you've ever used it at the office or a coffee shop, this is what you are using. It is the absolute backbone of modern Wi-Fi. Now, this is the complete opposite of an ad hoc network. Here, everything, and I mean everything, goes through a central hub. We call it a router, but technically it's an access point. All your devices, your laptop, your phone, your TV, they don't talk to each other directly. Nope, they talk through the access point. It's basically the traffic cop for your entire network. And this is how these networks grow. You start with a single little island, which we call a basic service set, or BSS. That's just one router and all the devices talking to it. But what about a huge office or university campus? For that, you link a bunch of those BSS islands together to create one giant seamless network. That's called an extended service set, or ESS. To you, it just looks like one big Wi-Fi network, but it's actually a whole bunch of them working together. All right, so a standard infrastructure setup works for most places. But what happens when you need something more? Like, how do you cover a massive outdoor area or build a network that absolutely positively cannot fail? For that, we need to get a little more advanced. So let's quickly run through three of these. First up is mesh. In a mesh network, all the nodes can talk to multiple other nodes. So if one connection fails, the data just cleverly finds a different route. It's self-healing, which makes it incredibly reliable. Then you've got point-to-point. Think of this like a laser-focused wireless bridge, a super direct link between two specific locations, like connecting two buildings across the street. And finally, point-to-multipoint is the opposite. You have one central point that broadcasts out to lots of other points. This is exactly how many wireless internet providers deliver service to homes in a neighborhood. But, you know, in the real world, things are rarely that clean and simple. Most large networks are actually hybrids. You might have a big corporate campus that uses a standard infrastructure network inside each building, but then connects those buildings together with a powerful point-to-point link. It's all about mixing and matching to get the job done. Okay, so we've covered all these different types of networks, but there's one last piece to this puzzle, and honestly, it's a bit of a mind bender. It's the difference between how a network looks on paper and how the data actually moves through it. So check this out. When you look at your home network, the physical layout is a star topology, right? All your devices connect to that one central point, the router. But logically, the way the data moves, it often acts like a bus. Think of it like this. Your router basically yells out a message for your phone. Your laptop and your smart speaker both hear that message, but they see it's not addressed to them, so they just ignore it. Only your phone actually listens and processes it. So the physical wiring isn't the same as the logical path the data takes. Pretty cool, right? All right, let's pull all that together real quick. What are the big takeaways? 1. Ad hoc is for those direct, temporary, device-to-device connections. 2. Infrastructure, from a single BSS to a giant ESS, is your standard Wi-Fi with a router in the middle. 3. Those next-level networks like mesh, point-to-point, and point-to-multipoint are all about solving specific problems like range and reliability. And 4, the big one, how the network is physically laid out isn't always how the data actually travels. So here's a little challenge. The next time you're on Wi-Fi, just for a second, try to picture the map behind it. Are you in a simple BSS at home, a sprawling ESS at the mall? Or did you just airdrop a photo and create a tiny little ad hoc network without even thinking about it? Because once you see that hidden map, you'll never look at Wi-Fi the same way again.